Hello everyone, I welcome you all to this class. This is mathematics class and we are looking at this topic, solution of ODE, solution of ordinary differential equation. We have introduced this concept in our previous classes, ordinary differential equation, and today we want to look at a solution of ordinary differential equation, solution of ODE. Now, a solution to a given ODE is a function, is a real valued function, which is defined on a subset of real numbers and whose values are what? Real numbers. So that's why we call it real value function. So the solution to a given ODE is a real value function that will satisfy that given ODE at all points of the independent variable on that domain in which it is defined, D. So I have a real valued function which is defined on a domain D, which is a subset of real number, now whose values are real numbers. Then that given value, then that real valued function is a solution to that given ODE if that given real value function satisfy that ODE at all points of what? The independent variable on the domain in which that function is defined. So let's look at this example. They say, is the function sine 1 over x a solution of the differential equation x squared y prime prime plus 2xy prime plus y over x squared equal to 0 on the domain? The first domain is 0 less than x less than 1. The second domain is the open interval -1, 1. So let's consider the first domain. The first domain, so solution. So let's look at the first domain solution. We are looking at the first one. Our domain D is 0 less than x less than what? 1. This is our domain, right? Now you have to know whether this function is defined on that domain. They say that function must satisfy that given ODE at all points of the independent variable. The independent variable in this ODE, the independent variable is x, because x does not have prime. So the one that have prime is the dependent variable. So y is the one that having derivative sign. All this prime is just the derivative sign. So y is the one that has the derivative sign. So y is the dependent variable, y x is the independent. Now your solution of an ODE is always a function of the independent variable. So this we are having that this function, we are given something, given y is equals to sine 1 over x. So y is sine 1 over x. That's what is given to us. So looking at this function, we want to check whether this function is defined on this domain, right? You know, sine is an entire function, which means that sine function is defined everywhere on a real line. But you know, infinity is not a real number. So, and in this place, the angle of sine is written in fraction form. We have 1 over x. So we know that this angle, this sign will not be defined if we are having infinity here. So what will make this thing to be infinity is only if the denominator is what? 0. It's only if the x is 0. But look at our domain. Our domain is 0 less than x less than 1. So we are having strictly less than. So 0 is not among and 1 is not among. So since 0 is not among, nothing will make this denominator to be 0. So this 1 over x cannot be infinity, which means that 1 over x on this domain will always be giving you real numbers, because 0 is not here that will make this thing to be infinity. So because of that, this function is defined on this domain. Now you also, when you have to check whether that function satisfies this equation. Also, for you to do that, you are going to differentiate this function, and check whether the left hand side will give you the right hand side. The right hand side is 0. So you check whether the left hand side will give you the right hand side. So what is your function? See your function here, y is equal to sine 1 over x, right? So for us to check that, we have to check get y prime prime, get y prime, right? And then now substitute. Now let's check what is y prime. Let's differentiate this function. Now if you want to differentiate this function, this is, you use what? Chain rule. You differentiate the inside. So if you differentiate 1 over x, 1 over x can be written as x raised to power negative 1, right? So that if you differentiate this, you use what? Power rule of differentiation. You bring down the power, negative 1 times, you remove 1 from the power, you remove 1 from it, right? So you now have negative x, negative 1 is negative 2. So you have negative x raised to power negative 2. Then you now differentiate the trig. You differentiate the inside, use it to multiply the derivative of the outside, the trig. If you differentiate sine, what will you get? You get what? Cosine, positive cosine. So this will be positive cosine of 1 over x. Right? That's what you get if you perform the derivative. So we have gotten our y prime, right? And this y here is original function given to you. Then this place, we need our y prime prime. So of course, you, as you are differentiating, you check whether the derivative is also what? Continuous. From what we got here, we have this expression. Of course, the only cosine also is continuous, is a continuous function on the entire real line. So, and the only thing that will make it not to be continuous is if this quantity is not a real number, if it is infinity. But as I explained earlier, nothing will make this thing to infinity because your denominator cannot be 0 on this domain, since 0 is not in this domain, right? So this is also continuous. So you now differentiate again, y prime prime, right? We use product rule at first. So if you use product rule, then you differentiate this and keep this, right? So if you differentiate this, you bring down the power. So I want to differentiate negative x raised to power negative 2, right? I'll bring down the power, negative 2 times negative x raised to power negative 2. You remove 1 from the power. So well, negative multiply negative positive, 2x, then negative to negative 1 is negative 3. So you have 2x raised to power negative 3, right? You are holding cosine of 1 over x. You are holding cosine. Then what's the next thing? The next thing is this time around you put plus, you differentiate the cosine, right? You differentiate cosine 1 over x, then keep this one. You keep this one. So if you differentiate this cosine, you differentiate the inside, right? You differentiate the inside, you differentiate 1 over x. You are going to use chain rule here. You differentiate the inside. If you differentiate 1 over x, we have already done this before, it gave us negative x raised to power negative 2. So you are going to have negative x raised to power negative 2 times, you differentiate the outside, the cosine. If you differentiate cosine, you get negative sine. So negative sine 1 over x. So this quantity will give you what? This quantity will now give you positive x raised to power negative 2 sine 1 over x. That's what it will give you. Then when you will now keep this one. Remember, you are keeping this one. So this is what it will give you. You will now keep what? You are now keeping x raised to power negative 2. We use what? Product rule, right? We use the product rule. So we differentiated this quantity first. This is what it gave us. Now we now differentiate this second one. It gave us this one, right? We use it to multiply the first one we are keeping. You are keeping this one. You now have negative x raised to power negative 4 sine of 1 over x. So that's what you have. You understood what we did here. I differentiated this one at first. I kept this one. It gave me this. Now I'm keeping this one, I'm differentiating this one. The derivative of this one gave me this quantity here. So what do? You will use this to multiply the one we are keeping, right? Yeah, so I'm supposed to do negative x raised to power negative 2 multiplying this quantity I got here, x raised to power negative 2 sine of 1 over x. So what do? You add the index of the x. Negative 2 negative 2 is negative 4, and you have negative here. So that's why it gave us negative x raised to power negative 4 sine 1 over x, right? So this is what we have gotten the respective things we needed. We got y prime prime, we got y prime, and we have our function y. So we can substitute. So we are going to start with the left hand side. So you start with the left hand side, you substitute those values in the left hand side and show that it will give you what is at the right hand side. What is at the right hand side is 0, right? So let's write what we have at the left hand side. We have x squared y prime prime plus 2xy prime plus y over x squared. So that's what we have at the left hand side, right? So I have x squared into y prime prime is this quantity here. So let's put it here. I've written this x squared. I will put it here. So I'm having this is my y prime prime. I'm having 2x raised to power negative 3 cosine of 1 over x plus minus x raised to power negative 4 sine of 1 over x. Then next one is what? Plus 2x into what is y prime? This is our y prime. Negative x raised to power negative 2 cosine of 1 over x, right? Cosine of 1 over x plus the last one, y over x raised to power 2. Y is the given function, right? But this y over x raised to power 2 can be written as y times 1 over x raised to power 2, right? Then you can use law of indices here. So this will be y times x raised to power negative 2. If you want to remove this 1 over, you introduce negative on the index. So this one will be x raised to power negative 2y. But what is your y? Y is sine 1 over x. That's our y. So what do? You open the bracket, come to this place, x multiplying 2x raised to power negative 3. You add the index. 2 plus negative 3 is what? Negative 1. So you are going to have 2x raised to power negative 1 cosine of 1 over x. Then this this x raised to power 2, this x raised to power 2 will multiply negative x raised to power negative 4 sine 1 over x. So you add the, if this x raised to power 2 multiply negative x raised to power negative 4, you add the index of x. 2 plus negative 4 is negative 2. So you have negative x raised to power negative 2 sine of 1 over x. Then if you come here and multiply, 2x multiply negative x raised to power negative 2 cosine 1 over x. So 2x multiply negative x raised to power negative 2. You add the index. Index of x here is 1. Index of x here is negative 2. If 1 plus negative 2 is negative 1. So you now be having, but you have negative here in the multiplication. So you have negative 2x raised to power negative 1 cosine of 1 over x, right? Then we'll have the last one, plus x raised to power negative 2 sine of 1 over x. So what will happen? This quantity will remove this quantity will remove this quantity. So we'll have what? 0 at the end of the day, which is our right which is our right hand side, right? So what is our conclusion? Therefore, sine 1 over x is a solution to the given ODE on this domain 0 less than x less than 1, right? It's a solution to it. Why is it a solution? It satisfies the ODE and it is continuous. This function is continuous on the domain. The derivative too, they are continuous on the domain, right? As I explained earlier. So let's look at the second one. The second question, question II, right? What's the domain? Our D is negative 1 comma 1, and we are given y is equals to sine 1 over x, right? So we check whether this sine 1 over x is continuous on this domain D. Now, sine, I told you that sine is an entire function. It is continuous on every real number, right? So the only place it is not continuous is if you are having infinity, right, which is not a real number. So the only thing that will make this angle of sine, this 1 over x, to be infinity is if the denominator is 0, because this is a fraction. We know if the denominator of a fraction is 0, we will be having what? Infinity. So if this denominator, if x is 0, you will now have 1 over 0, which is infinity. So that's the only time it will not be a real number, because infinity is not a real number. So if you look at your domain, numbers from negative 1 to 1 on your real line, 0 is there, right? 0 is there. If you check numbers, this is your negative 1, this is your 1. At the middle, 0 is at the middle. 0 is at the middle. And if you put 0 here, 1 over 0 is infinity. So you'll be having sine infinity, which is undefined, right? Our statement is that that's not the function. This function sine 1 over x will not be a solution to that given ODE on this domain. So solution and a function being a solution to a given ODE, you have to consider the domain. You consider the domain in which the function is defined. So thank you so much for being part of this class. See you in our next class.